In this lab, we're going to play with xDot firmware, build a couple of sensor circuits, and show the results in the terminal of a computer. First, we will go to embed.com and we will select the option Boards under the Hardware menu at the top of the website. Then, we will select Multitext xDot option and we will click the option Add to Embed Compiler in the right section of the website. Here, it is required to sign up. Once we registered, we will open the Embed workspace by selecting the option Import Program. Then, we are going to import the program. As we can see, it is a C++ program that makes the xDot LED blink every half second. We then can compile it in the workspace. This will provide a .bin file as an output. The computer sees the xDot as a USB stick, so in order to charge the programs, we just need to drag and drop the .bin file into it. The xDot will save the program, eject, and then mount again by itself. Next, we can connect the computer to the device through USB interface and get the stats that the xDot is generating in real time. The second part of the lab consists of building a circuit using the xDot and the thermistor. This is the diagram implemented. In this case, we will need to create a new C++ program that reads the raw data from the ADC each 5 seconds and convert it to a Celsius. The GPIO 0 and ground pins in xDot are used as source, while the GPIO 2 pin in xDot is used to get the output values. Here, we use the reference provided in the lab. Then, we will compile the program and repeat the process of paste the executable output to the xDot folder. Once the program is running in the xDot, we can connect the computer to the USB interface and see the measurements taken by the thermistor. The third part of the lab consists of building a circuit using the xDot and an audio jack. This is the diagram implemented. On the audio jack, we only use the left and ground connections. On the xDot, once again, we use the GPIO 0 and ground pins as source, while GPIO 2 pin was used to get the output values. Once again, we will need to create a new CPP program that reads the raw data from the ADC, scales the voltage received from 0 to 2.2, and convert it to a log scale. This is to show the results in decibels. Once we wrote the program, we will compile it and repeat the process of paste the executable output to the xDot folder. Once the program is running in the xDot, we can connect the computer to the USB interface and see the measurements taken by the audio jack. The results shown here are the decibels of the song Bohemian Rhapsody in a maximum volume from an Android cell phone.